Okay, I'm not going to show shoot an entire video of me solving every single problem, but I will use problem 35 here as an example, and all of them basically can be modeled after this one. What you want to do when you're solving a problem like this with fractional coefficients, and we don't see them as fractional coefficients, it looks like x over 4. However, another way to express this or write this equation would be 1/4 x plus 2/3 equals 1/3 x plus 1/4. Okay, so x over 4 implies a 1/4 x. So there is a numerator of 1x in that fraction, not just x when you look at it. And the easiest way to solve these things is to find the least common multiple of all of your denominators. Okay, in this case we've got two different denominators, a 3 and a 4. So if we think about the multiples of 3, there's 3, 6, 9, 12, 15, etc. And we think about the multiples of 4, we go 4, 8, 12, 16. This 12 right here, that's your LCM, your least common multiple or lowest common multiple. Okay, it's also, if you were to add these fractions, that would be the common denominator you would use. But we aren't going to add these fractions. Instead, we're going to use what would be the common denominator, or the LCM, to get rid of all these fractions. Okay. Remember, one of the things we can do in solving an equation is multiply both sides of an equation by the same thing. Okay. And so in this case, we would multiply both sides of the equation by that LCM 12. And to make things a little bit simpler so you can kind of see them maybe from a standpoint of what you're used to seeing, when you're multiplying fractions by a number, you want to have a top and a bottom lots of times, for at least people like to see that. So multiplying by 12 is the same as multiplying by 12 over 1. So we are multiplying both sides of the equation by the same number. Now, since we're multiplying the entire side by that 12, we have to distribute it. Okay, so that means every term gets multiplied by 12. So to show you all the math and all its detail, I certainly wouldn't show all this detail if I was doing this problem. You can see I'm taking 12 over 1 times each of the terms. Now you have to remember, so I've got this 12 over 1 times each thing. It's kind of highlighted. Oops. That highlighting's a little bit dark. If we make that thing lighter. Yeah, let's turn down this and let's make it a little bit bigger. So each term is being taken times 12 over 1. When we multiply fractions, we take top times top and bottom times bottom. There's no cross multiplying. Just take the top times the top and the bottom times the bottom, and then you simplify it. But because we are using 12, 12 is a multiple of every single denominator in every single fraction. That's why it's a least common multiple of 3 and 4. That means 3 and 4 both divide into it evenly. So when we multiply and we go, well, I got to take 12 times 1 and 1 times 4, what you really want to do is think of it as I'm simplifying, because you're going to, hey, 4 goes into 12 3 times. Now my numerator is just 3 times 1, and my denominator is full of just 1s. So 3 times 1 is 3. I just end up with 3x there. That one got a little bit crowded, but I'll show you a little bit clearer fashion on this next 12. When I multiply it by 2/3, I would have to take 12 times 2 and 1 times 3, and then cancel. I'm just going to do my canceling first, and then I've just got 2 times 4, or 4 times 2, 8. And on the bottom I've got 1 times 1 now. Just like over here, the 4 canceled with the 12, making it 3, and that 4 just became a 1. Next fraction, where I multiply by 12, again I'm going to cancel the 3 from the 3 and the 3 from the 12. and so I end up with 1 times 4. And then my last one, I got 12 times 1 and 1 times 4. That's just going to be 12 over 4. It's just 3. And I dropped an x here somewhere. Right there, I dropped my x. And so by multiplying every single term by the least common multiple...
Please pardon the interruption. Just for clarification, you are to pass out your plans.
Get a little loud here for a second. So by multiplying every term by the LCM, we end up with a new equation here that doesn't have any fractions in it at all, and now we can solve it just like we solved all of our other problems. I'll subtract 4x, subtract 4x. I'm just getting all my variables on the left side. I get negative 1x or negative x plus 8 equals 3. I'll take any constants to the other side. Negative x equals negative 5. I'll multiply both sides by negative 1. And so I'm getting x equals 5. Okay? And a lot of students then, if they were going to test this, let's see if I can erase a whole bunch of stuff here. If they were going to test to see if that's correct, a lot of students back off at this point because they're like, oh, I've got to stick that negative or that positive 5 in to all of these fractions, and that isn't necessarily a lot of fun. I don't know where all that stuff came from, but we'll see if we can get rid of it again. Yeah, we're not doing so well. Last attempt here. Cut all that stuff out. Okay, so let's just test see if x equals 5 actually works. If I plug that 5 in, I get 5 over 4 plus 2/3. So there's my left-hand side. If I wanted to test or get a number for that, you can grab your calculator. I taught you how to use math. Go to fraction on your TI 83s and 84s. If you don't have one, get a common denominator. It would be 12. 15 over 12 plus 8 over 12. So 23 over 12 is the left-hand side. Let's compare that to the right-hand side. 5/3, plugging in the 5 for x, plus 1/4. Common denominator of 12, so I take it times 4 over 4. I take this one times 3 over 3, and I get 3 over 12. Add those, 23 over 12. So I can see that the check works. 5 makes the left-hand side equal to the right-hand side, and I'm done. The rest of the problems, I will just work those out, and then you'll be able to see the solutions. But I will use this technique in every single problem. I will find the LCM of all the denominators. I will multiply each term by that LCM, canceling as I do so to eliminate all of my fractions.